Alright guys, we're going to start talking about some circles and central angles, angles inside circles, and some arcs. Okay, so basically you have a circle, and every circle has a center. We're going to have its center C. Alright, a central angle is an angle that starts in the center. Okay, so you have an angle, the vertex is in the center, and it intercepts at any 2 points on the circle. This here, from here to here, this is called arc AB or arc AB. Okay, that arc, you can find the length of it, which we'll talk about later in a couple videos, and it also has a measure. Okay, there's the measure of arc AB. Okay, think about the protractor. See how it curves and we can find the measure of the angle? Well, the measure of the angle is down in the middle of the protractor, but the arc of that angle, think of the protractor, the arc of that angle is the measure. So in a central angle, the measure of angle ACB, the measure of the central angle equals the measure of the arc. Okay? So this was 40. The measure of AB would also be 40 degrees. That's a minor arc, minor, small. If it's larger than 180, minor goes between 0 and 180. If it's 180 to 360, that would be major arc. So the measure of arc in a major arc has to have 3 letters, 3 points, not letters, 3 points. It starts at A, goes through D to B, or it starts at B, goes through D to A. So the measure of ADB would be 320. Right?
Hello.
So that's a central angle. An inscribed angle, right? It's inscribed on the circle. The vertex is on the circle. The vertex is on the circle. So if it's inscribed, it's on the circle. And think about it, if it was central angle, we would pull it and we would just stretch it out. So what would be bigger, the angle at the central angle or the inscribed angle? Well, the angle on the central angle would be bigger. We're pulling it, we're stretching it. So the measure of angle QSR, okay, it intercepts the same arc. So if this were 40, right? Let's say this were 40, and I'm stretching it, is it going to be more or less than 40? Less than 40. Well, let's pretend this was 40. What might this be? Could it be 40? No. Think it's going to be more? No. What it is, it's going to be half the measure of QR. So this is going to be 20. An inscribed angle is half the arc. Central is equal to the arc. Inscribed is half the arc. The last thing we have is an angle created by a chord or a secant and a tangent. A tangent intersects a circle at exactly 1 point. Okay? At 1 point. So you have to think about a circle, going on a little side thing here. Think about a circle. Circle is infinitely many points. One a little bit lower than the other one. So I can actually find 1 point and I can intercept the circle there. That's the tangent. The word tangent comes from that. Many times in class, Mr. Bracco may go on a tangent. It has a little 1 point, one little small piece to do with what we're talking about, the whole circle, and it just goes off from that one piece. That's why someone goes off on a tangent. It's the same thing as a tangent line in a circle. It just has one little connection to what we're talking about, and then it just shoots off. But back to here, a tangent and a chord or a secant. Secant intersects at 2 points. The measure of this angle here is also half the arc. So this, when it's an inscribed, when it's 2 chords, or whether it's a chord and a tangent, it's always 1/2. So the measure of angle LKJ is 1/2 this arc measure LMK. Okay. That's just an intro, some terms, and a couple basic things. You'll have some worksheets you do with it, and we're going to apply them to areas of sectors and lengths of arcs.